Alright, we are looking at continuity at a point, and we're trying to find the constant a to make the following continuous on the real number line. And so in this video here we're going to be looking at this one right here. Alright, so this is what we got. We got this piecewise function, and it's in three separate pieces here. Where we got 2 is, let's see, f of x is equal to 2 where x is less than or equal to -1, and f of x is equal to ax plus b where x is greater than -1 and x is less than 3, and f of x is equal to -2 where x is greater than or equal to 3. So we want to find a and we want to find b that will make this continuous, I should say everywhere continuous. Okay. Alright, so the first place we're going to be concerned here is at -1. Is at -1. So, and then let's see, and then we're going to be looking at 3. Alright, so -1. So step 1, we do f of -1, and it exists, and it's equal to 2, right? Obviously, because we're using this one here because this says x is less than or equal to -1, and so for all values less than or equal to -1, f of x is going to end up being 2, right? And okay, so what about the limit? That'll be the next thing that we look at. The limit as x approaches -1 coming in from the left hand side, so we're obviously using this because this says x is less than, and so that limit is going to be 2. Now that looks like -2 there, but this is just a 2 right here. Okay, this negative means we're coming in from the left. Alright, so the coming in from the left, it's 2, and then we're checking it coming in from the right hand side, and this would be ax plus b, right, coming in from the right. And so you're just doing the direct substitution, taking -1, plugging it directly in, and we end up with a times -1 plus b. Now, for coming in from the left and coming in from the right, for this limit to exist, we have to set both these equal to each other, okay? And we do that. And then we want to solve for b in this problem, but or a and b. But we have an equation here with two unknowns, so we're going to need another equation with two unknowns. And so where we're going to get that is we want to check that now at 3. And so we go to f of 3, and that's equal to -2. Right? So if we look up here, right, f of 3, so because this says x is greater than or equal to 3, we use this one here, and it's -2. And so then we do the limit as x approaches 3 coming in from the left hand side, so we're taking this 3 and we're doing the direct substitution, plugging it in, and coming in from the right hand side, right, so coming in from the right hand side at 3 we get -2. Okay, so now we get a new equation, but it also has the unknowns a and b in it. So now we have two equations and two unknowns. And so this was our first equation, and I'm solving here for a in this equation. And now we have a relationship between a and b. A is equal to b minus 2. Right, and so in this last equation that we came up with, we take this b minus 2 and we plug it in right here for a. Plugging it in for a, and now we have an equation that involves just b, and then so we want to solve for b in this equation. So now we have b, right, after solving for b here, we have b, and then we can take b now and plug it back into that one equation where we had a is equal to 1 minus, or b minus 2, plugging b in, and we get a is equal to -1. So as you can see here, we got a is -1 and b is 1. And this is what our graph should look like.